All right, welcome back to the Nexus Podcast. Ric Derbyshire of Orange Cyber Defense is my guest, and we're going to talk about some research that was published recently that explores how an attacker might move laterally within operational technology environments. We've got a brand new catchphrase in cyber, living off the plant. That's a new one to me anyway, so welcome. Nice to meet you.
Thank you very much. Thanks for having me, Mike.
Yeah. Tell me a little bit about your background or career path. I think that's always interesting for people to kind of hear.
I've had one of those like weirdly generic but also kind of strange career paths. I did the whole like computer science at university and did penetration testing for a few years, but then went back and did a PhD in the most riveting topic of quantitative cyber risk assessment. But the university I was researching at also had a strong OT presence, and I kind of fell into it accidentally. And from there, it's kind of just been OT all the way. So I worked for a systems integrator for a year or so, and then I ended up in Orange Cyber Defense because it was a research-specific job. And once you get into research, it's kind of addictive, and you have to kind of get back into it. Yeah, absolutely.
Because it's funny. Like, there's no kind of direct career path to OT cybersecurity.
It's tragic. It's really difficult, and it requires a lot of investment, which is why working at a university that had a big test bed, it was a very fortunate position, so I properly grabbed that when I could.
Yeah. As I was looking at some of the materials sent me to help me prepare for this, it just didn't seem that there's a lot of either discussion or available research on lateral movement within OT environments. So is that kind of the motivation for you? Did you see a gap there, or was it something else?
No, it was actually accidental. In fact, we actually stumbled across this as a way to try and propagate a ransomware technique. And as we were doing that, we realized that we could be much more targeted and specific with how we were using it. And then we realized that we could basically proxy everything through it. So we could basically use certain library functions in one PLC to talk to another PLC, and we could abuse reads and writes and all sorts of things through doing that. So we kind of accidentally stumbled across it and then just rolled with it. But there has been some other work. So there's a researcher in the Netherlands called Jos Wetzels who basically did a really like comprehensive look at it a few years ago, and yeah, this doesn't really contradict it or anything. It kind of complements it quite well. So it's interesting.
So I think traditional lateral movement is sort of understood between IT assets, or maybe even between IT and OT. How much more difficult is it to get into, through the DMZ on the Purdue model into, the field assets, which is what your research is about, just kind of moving between those field assets?
It's really difficult purely because when you're doing lateral movement between, say, for example, two IT assets, you're basically going from one more or less remote code execution to another remote code execution, whereas that kind of TTP isn't something that you typically find or do that frequently in OT. You're not using remote code execution that frequently on programmable logic controllers, for example. So instead, we're having to use the actual native functionality that is just there on the PLCs as part of its general day-to-day life, essentially.
Sure.
So it's not quite as persistent. Maybe it would be appropriate to say it's kind of like hybrid proxy / lateral movement, because it's not quite as permanent, but still it does laterally move. You can do all of the functionality you need through it.
Because more understood attacks against PLCs are like manipulating upload and download data. Is that fair to say, or?
Yeah. Like, so for example, Stuxnet is manipulating data downloaded to the PLCs. But this is much more utilizing, for example, this is Siemens specific, so it's abusing the S7COM protocol, and it's abusing specific library functions that are typically used to communicate between PLCs. So we're basically just piggybacking on those library functions.
Moving between OT assets that way, what are the barriers? Why is this so difficult? Or is it just hasn't been explored very much?
I don't know. I think one of the reasons that I guess it hasn't been explored is because it's not really necessarily being seen as necessary. Typically, you kind of assume that network segregation is the main defense in operational technology. It's like the kind of like the final, it's like perimeterizing everything. So we just assume that network segregation is going to work and that's going to be fine. So if the adversary can only get access to one PLC and it can't get access to more, then they can't do anything about it. But I don't know. I guess maybe because it's more, like I say, using this living off the plant kind of approach, that's just native functionality, which doesn't seem to be that prevalent in current research. A lot of the research is still quite cyber focused, so it's maybe not so much focused on the OT infrastructure, OT like functionality itself. It's a hard one. Yeah. I have no idea.
Obviously, living off the land attacks got a lot of attention with the typhoons and the activity of that group on critical infrastructure. Is the main advantage of using that type of technique, is it just because it just blends in, it looks like normal traffic, it doesn't look malicious, or are there other more subtle advantages to it?
So that's one of the main advantages, and that's where it kind of it mirrors a lot of like the typical living off the land advantages that you'd see in IT. But one thing that we noticed when we were collecting a data set of publicly reported cyber attacks that had cyber physical impact was that there were this small set of impacts that we saw that were unique to attacks that had included the use of OT tactics, techniques, and procedures. And the majority of those tactics, techniques, and procedures that are specific to OT are native functionality. And what we saw were the impacts that we were really scared of. Things like manipulation of control, loss of protection, damage to property, loss of safety. These are the kind of things that we actually talk about and we worry about when we talk about cyber physical impacts. So when we separate those out, we say, hey, these are the ones that we're actually seeing. It kind of makes sense to start pursuing this as a research path and say, can we actually see, are there patterns there? Or, I mean, unfortunately, most of my kind of research is troublemaking. So kind of making it worse, I guess. But at the same time, we've had really good vendor responses when we've like kind of published this. And so I'm hoping we're making the world a better place in some way or another.
Yeah. You're right, though. This is largely unexplored territory. I mean, there's only a dozen malware samples that have really been written specifically for OT. Even on the attacker side, this is kind of like still niche, right? I mean,
yeah.
So with PLCs, is there still a certain air about them that they're kind of untouchable, that they're, I don't want to say kind of walled off, but...
I don't know whether untouchable...
Or air gapped, I guess.
Yeah, so we assume that they're air gapped, but also we assume that they're kind of assumed to be actually extremely vulnerable, but at the same time vulnerable in a very specific way, I guess. One of the things I try and preach is that just having access to the OT doesn't mean that it's game over. In order to actually be able to make a PLC do something that's actually useful for an attack narrative, unless you just want to have that PLC break and turn off, which by all means is a very viable impact to cause. But if you want to do something stealthy and persistent over time, so it's actually doing something very specific, then you need to know more about the environment that you find yourself in as well. So one of the other things that I've been trying to, I guess, preach is this idea of process comprehension and understanding the need for an adversary to understand the physical environment that they find themselves in, and also how the OT basically controls, automates, and monitors that physical environment, how the cybersecurity controls and network architecture are in place, the people, and then the physical security and the safety features are all, how it all works together in that specific victim environment. And then once you know that, you can start to actually construct an actual really meaningful and specific attack. And I think that's kind of lost on many cases when we kind of just say, oh, well, once you get there, it's game over, it's really easy. Because that kind of then just dumbs it down to just turning the PLC off is enough, which comes full circle too. That might be enough, but in some cases it isn't. Yeah,
I've heard PLCs characterized as dumb assets, and it's highly unfair because obviously they're carrying out very specific, sensitive process work. So, have you heard that characterization as well?
I think it comes from the whole idea, there's a lot to do with, whenever you speak to anyone about OT that isn't necessarily fully familiar, they'll just say it's just a load of old computers and, the references of, Windows XP being the main operating system in the environment. And by all means, many environments that you find yourself in are maybe legacy and old, but even those, the environments that haven't been updated in 10, 15 years, they're still quite advanced, in fairness. So they do still quite take a bit of learning once you get in there and really to understand how you would manipulate it.
I mean, this is really almost the realm of very advanced attackers if they're targeting PLCs, because I would imagine, and correct me if I'm wrong, you need to do your homework on the vendor, on the controller. You need to understand the way it works, right? I mean, what kind of homework goes into this type of research from that angle?
A lot. Yeah. So you can categorize it as two kind of things. Firstly, you need to know about the actual background. How if you're attacking a water treatment provider, how is water treated in general? So what do those processes look like at an abstract level? And you also need to know how the victim's specific vendor technology works as well, because those ecosystems are quite varied and they have different vulnerabilities. They have different things you can take advantage of. But also, once you get in there, it's that case of process comprehension and really needing to understand what's unique to that environment you found yourself in as well.
Mm-hmm. All right, so tell me a little bit about your research, specifically the living off the plant aspect of this. I know you guys developed a technique. Take me through it from a high level.
So the specific lateral movement technique is essentially abusing communications library functions that reside within Siemens PLCs. So they're called put and get. And put essentially is a write function. It's how PLCs tell other PLCs or HMIs specific, write things into a remote PLC's memory. And get is basically how they can read remote memory from a PLC and bring it locally. And what that actually ends up being is a really neat read and write function. It takes a few extra steps to read and write every byte on an external PLC, but essentially what we found was that previous research where we were abusing the S7COM read and write function anyway can just be replicated using put and get. So we can basically say, to get, read this byte, and then read another byte, and then read another byte, and then we bring that all locally and we can reconstruct it. And then once we've downloaded entire data blocks worth of memory, we can see the length of that data block and where certain 0 bytes are that are always going to be there in specific data blocks. And then we can create signatures or match signatures, I guess, that we've already created to identify which library functions are running on a PLC. And then once you know what library function is there, we know where the variables are in memory, so we can precisely know which variables are what and what values they have. And if we want to manipulate them, we can then write into those variables as well from a hop away. Mm-hmm. So yeah, it's quite a simple thing, really. It's basically using another PLC's read and write function. So it's quite simple, but. Yeah, it's a bit of a brain melter to try and implement because of the amount of things you have to do, because you have to say, read this from this external, put it in this local memory, and then we read that, and then we keep going around. So it's about 5 or 6 steps. It gets extra confusing because we can chain these together. So we can do it from PLC 1 to PLC 2, but then we can tell PLC 1 to tell PLC 2 to do it to PLC 3 ad infinitum. So when we try to do it to 3 PLCs, it's possible. It's very, very slow because we're doing about 5 writes per each request. But yeah, it works. It's just really confusing.
And what kind of access would an attacker need? Is it local physical access or
just network access? So if they've compromised the machine on the OT network that has network access to the first PLC, they're basically ready to go. It just has to the PLC has to have port 102 open, which is for S7COM, and it also has to have put and get already enabled and be configured to speak to another PLC. Mm-hmm. And then we're just good to go.
And are you bypassing any native protections or any features that are supposed to be enable a little bit more security, a little bit more protection on the device?
Not really. No, okay. So there are certain functions and features that can be implemented that may slow it down, that may make certain aspects difficult or may make certain things not as good. But typically what we find is these kind of security controls are either just not implemented because they cause compatibility issues with other devices on the network, or the systems integrator just hasn't bothered to implement them in the first place anyway. So typically what we find is this isn't wholly unrealistic to just say this is just going to work carte blanche on most environments that you find this kind of setup in.
Mm-hmm. So what would some of the controls be? Just the authentication between the devices, or?
So yeah, I mean, this affects like some more slightly legacy devices. So this is mainly targeted at S7300 PLCs, which are fairly old now, but they're still very widely deployed.
Sure.
But again, so the actual enumeration, there's a security control called block optimization, which makes it difficult for us to actually fingerprint the what's going on in memory. So we then can't really understand what's going on. But they're just typically not that frequently implemented.
Right.
So we caveat this in the research. We make sure that these things are known. Like there are certain things you can do, but they come themselves, like I say, with their own disadvantages of implementing them.
So what would an attack look like? I mean, you're not necessarily injecting code.
No. I mean, it would. So yeah, we're not injecting code. We're not like downloading configs to the PLCs. We're basically being able to read the memory that's there and then write into it. So, for example, in the demo that I presented today, the idea was that we had access to one PLC that was acting essentially as a relay between another PLC on a remote site that was controlling a tank that had an inlet and an outlet valve, and it was also had a count feature so that it could only outlet 20 decaliters a day of fluid or whatever.
Mm-hmm.
And so what we did was we used the read function to enumerate what was on the PLC. We enumerated the count function, worked out what was there, and then wrote to the count function and overwrote up where it was at, which was at 20, back to 0, so that we could unload another 20 decaliters. And then we also overwrote the output in the outlet valve to basically make sure that the valve opened.
Mm-hmm.
So then we're basically overwriting actual operational variables that control the physical environment and also like manage how much the physical environment is constrained.
Mm-hmm. So if you're not watching for these variable changes, these are pretty much undetectable until it's too late.
I mean, they're expected. Right. They're expected on the network as well. So if we're using them, how do you tell the difference between an adversary telling a PLC to tell another PLC to do something, or the PLC just telling another PLC to do something because that's what it's supposed to be doing, which makes it incredibly difficult. That's the same with the stealth that comes with living off the land in IT. It's just the same. It's really difficult to defend against.
Right.
Which is one of those things when I release research like this, I always find it really difficult because people are like, so what? And it's like, I kind of don't know. Like, yeah, it's really difficult, and I think we have a big challenge on our hands to distinguish between legitimate and illegitimate traffic when they look almost identical.
But the risk is disruption, damage, etc., correct?
Yeah, significant.
It's a real
I mean, even like long-term espionage, like that could be a feature as well if you're just reading from another PLC.
Mm-hmm.
Even just reading like how much fluid is in a tank over the course of a day, if that might be important to you for corporate espionage, for example.
And so you mentioned a couple of times that you used the Siemens S7 in your research. Do you think other PLCs, other vendors are in scope as well, or?
I'd be hesitant to say yes, just because I haven't looked at them. But possibly. I don't think this is unusual functionality. It might be implemented different, or I don't know. I think that may be the next step.
Yeah.
We might see if it exists in other vendors as well.
And I assume you brought this to Siemens. Just curious as to, in terms of a fix, I mean, is this kind of going back to the drawing board for them, or?
So because it relates to one of the PLCs that's basically end of life, they aren't regulated to do that. They don't need to. Sure. So they aren't doing anything technically about it, but they every time we come to them with some of like these really weird vulnerabilities, this kind of thing, they're really receptive. They're really good guys, and they'll put things in documentation, for example. So I mean, it's the most that they can do really at this point, because they can't really be going and rolling out significant architectural fixes to something that is decades old at this point, and it would probably cause problems to the many environments that are using it right now as well. So it's difficult for them to try and do a technical fix.
Yeah, and I mean, that's a core OT problem across the board for a lot of these legacy assets that are out there. So what can defenders do about this? What should they be doing about it? I mean, if assuming somebody picks up your research and runs with it.
So for example, to actually try and start detecting native traffic, using vendors that can pick up native protocols and things like that, like OT specific vendors, those that are really like picking up like native traffic, and also focus on confidentiality as well. I know one of the main mantras in operational technology is to focus on safety and availability, and that makes a lot of sense. They are the priorities. But if you also consider that confidentiality of your process data is really important, if you deprive an adversary of data about your environment, it makes it much harder for them to understand what's going on and for them to build up a more sophisticated attack. So they're not going to burn their access on an attack that they aren't certain about. They're not going to just go ahead and do something when they think, oh, actually, this might just not work and we're going to burn our access. So what you're doing there is essentially finding out or giving yourself more time. You're making them wait and try and spend the time to find more data, and all of that time that they have to spend additionally is more time that you have to detect them in your environment. Mm-hmm. And then a couple of other more long-term things I was suggesting as well were, for example, to actually train your OT cybersecurity staff on OT-specific training, not just like the typical OT security training, but actual OT specific, like whatever vendor that your organization uses for PLCs, go on their training. Go and learn how that specific process works. So, for example, if you work in water treatment, how is water treated? Do you know how that works? Do you know how that works in your specific environment? Because once you bring that back to the cybersecurity discipline, then you can start working out where the actual the crown jewels are, so to speak. Yeah. And finally, having a more pessimistic view of there's a huge challenge in detecting this, and even more so in preventing it. So start to think how you can build in resilience by design. So if things need to fail, open or close, do whatever is appropriate. If you can bake in redundancy so you can fail over to a different process, do that. If you can, for example, have physical safety and security controls that aren't documented in the OT environment, that are really difficult to find out, just implement those so that the adversary doesn't know that there's something there, and then they can't even circumvent it if they do know it's there, because it's a physical control, not a cyber control.
So just as a final thought, do you think that data integrity, data protection is kind of like the next OT security discipline, maybe for lack of a better word?
I don't think it's ever going to be more important than safety and availability. But I think we will start to see the value of data, whether that be current telemetry in the environment, or that is piping and instrumentation diagrams and things like that, and just how everything is put together. I think all of that is really useful to an adversary. And as this gets more challenging, as we face more adversaries that are getting better and building capability to be able to do this, and they become more common, I think anything that we can do, like every little helps. So starting to deprive them of that information is a valuable thing to do.
Yeah. All right, Rick. Thank you so much for joining me. I appreciate it.
Thank you so much for having me. It's been really nice. Thank you. Cheers.